Adding and subtracting fractions is going to use equivalent fractions like we did when we did the scale up equivalent fractions. We cannot add two things that are partial unless the pieces are all the same size. So in order to do that, we have to make sure that their denominators are the same because that means that their pieces have been cut into the same size. So for example, if we were going to add 3/4 and 1/6, which is a common starting place when kids learn fractions. That means that we have to figure out what number or what multiple of 4 and what multiple of 6 are going to be the same. Now, many students will just multiply by the denominator of the other fraction. However, if we do that strategy, then that means we're often going to also have to reduce because we're not going to choose the least common multiple. And again, this is where knowing your math facts is going to come in super handy because I know if I multiply 4 times 3, I'm going to get 12, and I can also multiply 6 times 2 to get 12, which means that would be my common denominator. If I was using the multiply by the other denominator strategy, then I would do 4 times 6 and get 24, which is a much larger fraction. You can still do it that way, but it does mean that then you are going to have to scale those fractions down and reduce them because they have an extra factor of 2 in them. So if we were going to do it with the least common multiple strategy, then that means I would say 4, 8, 12, 16, 20, and I would do 6, 12, 18, 24, 30. And we can see by making our list that like we did with least common multiple, that our least common multiple is 12. I see that 24 right here. That would be the next in this line right here. So we're going to multiply by 12. And again, as I said earlier, I know that when I do multiply, I'm going to multiply the 4 times 3, because 4 times 3 will give me 12. And I'm going to multiply the 6 by 2. And whatever I do to one part of the fraction, I have to do to the other part of the fraction. So my new addition problem is going to be 9/12 plus 2/12. When we add fractions, we add the top numbers. So that's going to give us 11. And then our denominator is going to stay our denominator. We do not add the bottom part of the fractions. So once we get the common denominator, we are done working with the denominator, and that number is going to stay until the end. It's always a good idea to look because sometimes when you add two fractions together, they will still be able to be reduced. And it's good practice to always reduce fractions to their lowest terms. When I look at the answer, I can see that the number 11 in the numerator, and I know that 11 is a prime number, and so I know I don't have to worry about reducing it. It's going to take a long time for students to make these recognitions of when they need to reduce and when they don't. And so that's when it's important for them to at least think about what prime and composite numbers are and perhaps have a list of the prime numbers so they can check while they start to internalize that information. So subtracting fractions uses the same process. The only difference is going to be that in that last step where you add the numerators, this time we're going to subtract the numerators. So let's go ahead and do an example of subtraction. So my original fraction is going to be 5/8 minus, we'll do 1 minus 1/12. So in this particular one, I could make my list. I would say 8 and 16 and 24 and 32. And I would do 12 and 24 and 36. And I can see on this example that my least common multiple would be 24. If I multiplied 8 times 12, that would give me 94, I believe, which is a much larger number, and we don't want to do that. If I wanted to, let me get rid of all of that. If I wanted to instead do the the greatest common factor type, then I would say 2 times 2 times 3, and I would say 2 times 2 times, oops, 2 times 2 times 2, and 2 times 2 times 3. My brain and my hand were not moving at the same speed. So I can see here that this is in common in both fractions. So that means I have 2 times 2. And then to find their least common multiple, I would multiply these down here as well. So this gives me 4 times 6, which gives me 24. So that's another way that we can also find the least common multiple and also common denominator. But we've determined that our common denominator is 24. So I'm going to go ahead and multiply top and bottom of the 5/8 by 3, because 8 times 3 gives me 24, and top and bottom of the second fraction by 2, because 12 times 2 will give me 24. And my new problem is going to be 15 over 24 minus 2 over 24. So again, remember we just subtract the top parts to get 13. And then the denominator is going to stay the 24. Common mistake that kids will make is they will want to add or subtract the denominators. It's less common in subtraction, since that's going to make them end up with a 0. But if they don't remember to find the common denominator, it's a very common mistake. So that is how we add and subtract fractions. Find your common denominator, rewrite your fractions into equivalent fractions, and then either add or subtract the numerators, and the denominator will stay the same in its new form.